So in this video, we're going to do question 63 from chapter 26, which is what are the electric fields at points 1, 2, and 3? Give your answer in component form. We start out with a charge of 5 nanocoulombs, and then we have 3 points at which we want to find the electric field at. So this will be 1, this will be 2, this will be 3. And so let's draw out the graph for them. And so this will be 1 centimeter, and these are each 2 centimeters. And so now we want to find the electric field at all three of those points. So the formula for the electric field is E hat equals K Q R hat over R squared, where R hat is always away from Q. Okay. So now we want to find the electric field at point 1. So we'll first plug in the numbers into the equation. So we will have E1 equals 9 times 10 to the 9th times 5 times 10 to the negative 9th nanocoulombs over R squared and R hat. So what is R squared? Well, we have here a triangle, and so we know that the hypotenuse of a triangle is a squared plus b squared. And so for R squared, we can put in 9 times 10 to the 9th, 5 times 10 to the negative 9th columns, R hat, over a squared plus b squared, which will be 0.02 meters squared plus 0.01 meters squared. And so when you plug this in and figure this all out in a calculator, you will get the answer 9 times 10 to the 4th newtons per coulomb. So that's the first part of the electric field for first one, but now we need to find the component form. So we will use the equation E hat equals E cosine theta plus E sine theta. And we will plug in the appropriate numbers. So now we have to find theta, and so theta is equal to the inverse tangent of that triangle that we mentioned before, so 0.02 meters over 0.01 meters, and this will equal 63.43 degrees. And so now we can just plug in all the information we need into the equation. So we will have E hat equals E1, so that will be 9 times 10 to the 4th times the cosine of 63 plus 9 times 10 to the 4th times the sine of 63, that's 0.43. And so we will use a calculator to solve this, and we'll get the answer 4.02 times 10 to the 4th I plus 8.05 times 10 to the 4th j. And that is the answer for the first electric field. Now we're going to go on to find the second electric field. And so we'll use the same equation as before. which is the E hat equals KQ R hat over R squared. And we will plug in the numbers once again. So we'll have E2 equals 9 times 10 to the 9th, times 5 times 10 to the negative 9th columns, R hat over the distance squared, which is 0.01 meters squared, since it's just horizontal. Before, like as you can see here, it's just a horizontal 1 centimeter. And so we'll just plug that in the calculator and get the answer 4.5 times 10 to the 5th. And now we need to find theta. Well, you can see that theta is 0 since it's just a horizontal line. And so we're just going to plug in theta, and we're going to get this equation, cosine 0 plus E2 sine 0. And we'll plug in some numbers for that, and we will get 4.5 times 10 to the 5th times cosine of 0 plus 4.5 times 10 to the 5th times the sine of 0, and we will get the answer. Since it cancels out, we get 4.5 times 10 to the 5th I, and that's the component form for the second electric field. Finally, we're going to do the third one. We're going to use the same equation as before. And so we're going to have E3 equals 9 times 10 to the 9th times 5 times 10 to the negative 9th columns, R hat, over. Now remember, before we did the a squared plus b squared equals c squared thing, and so we're just going to do that again since it's the same distance. So 0.02 meters squared plus 0.01 meters squared. And so we are going to get the answer 9 times 10 to the 4th. And since we know the angle from before, and it's the same angle but downwards. Let me see if I can. The same angle, just down this time. We know that theta equals negative 63.43. And so now we're just going to plug in everything we have into the equation. And so we're going to get E3 equals 9 times 10 to the 4th cosine negative 63.43 plus 9 times 10 to the 4th sine of negative 63. And we are going to get the answer 4.02 times 10 to the 4th I plus 8.05 times 10 to the 4th j, and that's the component form for the third electric field.